Okay, hello everyone. Well, that I didn't. I'll. Why everybody's having the same issue? When I did the day you weren't because you were sick. I'll put your name and I'll look it up. You can submit again. Submit again, Justin.
Professor,
Yes.
are people having a problem with the quiz saying it's
Yes.
not been submitted?
Yes. And
Okay.
I don't know why.
Okay, I'll resubmit then.
Yeah, I don't really know why. This never happened before. So
Okay.
start sending me emails and I'm just telling them submit again, submit again. Honestly, I've been very, very sick and I'm not having the time to look into things. So,
No, I understand.
yeah, so I'm
I
just
do hope
telling,
you feel better.
I hope so.
Yes.
I'm tired.
Yeah.
Anyway.
I got a brother in the hospital right now with COVID pneumonia. So.
Oh, no, I don't have that, but it's a very, very bad infection. So hopefully the antibiotic starts kicking today.
Yeah.
Anyway, so we'll do our best to have our lecture today. I need your help. Let's see where we started. I think I left you with, if my memory is right, I left you with quadratic and I assigned some homework. So do you guys do them? Do you have any questions? So I don't introduce anything new. If you have any questions, just put them up, please. Anybody? I'll give you a few minutes to gather your thought. Okay, thanks. Okay, 2.8, number 15. Okay. All right. Some of the hypothesis is missing in number 15, so I'll fill in the details, okay? So last time, the only part we did, and then I'll come back to problem number 2.8, is that a quadratic function, those are, so we studied linear, as I've said, and they have this very specific format, a x squared plus bx plus c with the a different from 0. Okay, so that's a form of the quadratic. And I said that if a is positive and a is negative, if a is positive and then its graph is concave up, that was our scenario, and a negative, make the graph concave down, so that's a negative a. And the important one is that the vertex, that's the vertex. And that's the vertex. So the vertex is really where the function reaches its minimum value or its maximum value. Okay, so it's an important point. And what I told you last time is what's the x-coordinate. So the x-coordinate of the vertex, the x-coordinate of the vertex, of course we can prove that, but I opted no, is minus b over 2a. And the y-coordinate is nothing more than the output at this. Okay, so that was the idea last time. Okay, we're going to use this to go over number 15, and I will definitely fill in the missing piece of it. So number 15 is the following. A boy throws a rock straight up in the air. When the rock leaves his hand is 5 feet above the ground, and the rock is traveling at a speed of 80 feet per second. What was the maximum height of the rock? And how long after the boy reached the rock did it reach its maximum height? All right, so of course you couldn't do that problem because you don't know the formula for that. So the formula for that is the following. So if I call f of t, the height of the ball, height of the ball from the ground, ground is my reference, t seconds after the ball was thrown. So that's what it is. That's what f of t is, the height. And the formula for f of t is given the following. If you use the information and the formula that I should have given you, it's minus 16t squared. Usually in the formula for the height, the coefficient of t is the speed, is the velocity, that's what it is. And the 5 here is the height when t equal to 0. So when t equal to 0, the height is 5. And that's the formula for the height at time t. Very good. Now the question is, what was the maximum height of the rock? And how long after the boy threw the rock did it reach the maximum height? So basically, what they want us to do is the following. First, this is a typical quadratic. And one of the most famous example of quadratic is actually that function. It's the function that gives us the height of an object after you throw it. So that's one of the most famous example of a quadratic function. So this is my quadratic. That's the time. And that's f of t. And a here, I always, as I said before, I always tell you what the a's are. A is minus 16. B is the coefficient of t, which is the 80. And C is 5. So that's the whole thing. Okay. Now A is negative. It means we expected it, of course, to go concave down. So the curvature is down. Now, always it's nice to know what happened at t equal to 0. So you can have a decent graph. So if t equal to 0, it means if you plug in 0 in it, you get f of t equal to 5. So this is 5, which is f of 0. That's the 5. So the ball go up, go down, and finally it hit the ground again. Okay, so that's really the behavior of my ball. Okay, and the question is when it reached its maximum height and what is the maximum height. So basically, we want when, the time, because here the input is the time. So what's on the x-axis or on the horizontal axis is time, and on the vertical axis is the height. So this is the height here, and this is the time. Okay, and the question is when. So basically, that's what I want to find. That's exactly what I need to find. So when, that will give me the time. And when I find the output, I get the height. All right? Okay, so let's do it. Let's do it. So what's the time? So time when the ball, when the stone reached maximum height. Okay, so the time is minus b over 2a. That's how we're going to find the time. Means minus 80, that's the b, over 2a, it means 2 times minus 60. Okay, and this is going to give me 2 and 2, so it's going to give me 80 over 32. You can simplify by 4. So I divide by 4 both, and that will give me 32 into 4, which will give me, right? Actually, we can go by 8, which is 10. No, we can go by 16. All right. So if I get that, so it's 80 over 20, 16. So it's basically going to give me 5 over 2. Okay, divide by 16, divide by 16, 32 into 16, it's a 2, and 80 into 16, which give me a 5. So the stone reached its maximum height after 2 seconds and a half. Okay, that's when it reaches. And now the question is find the maximum height. So how are we going to find the maximum height? Very quickly. So now we find when it reaches its maximum height. Now we know we need to find the value of the maximum height. So what's the value of the maximum height? What do we need to find? Come on. Okay, now what's the maximum height? Okay, how would you find that? Go ahead, don't be too quiet. Plug it into T. Exactly. So we have to find the maximum height. I have to plug in 5 halves or 2.5 into the expression of the function. Means I have to plug in 2.5 right here into the expression of the function. So I will get minus 16 times 2.5 squared plus 80 times 2.5 plus 5. Okay, and this time I'm not asking you to give me the answer as one fraction or anything, so we can just evaluate this. So we have a nice number. So it's minus 16 power 2 plus 80 times 2 power plus 5. Okay, oh, of course I did a mistake. So it's minus 16. If anybody does it faster than me, please go ahead. Okay. 105. Thank you, Kayla. 105 feet. All right, and that will be the end of the problem. All right, so once I know the height, the formula, that's a typical quadratic, and then I can start answering the basic question. Find the maximum height. I mean, that's the natural question. When does it hit its maximum height, and what is it? So basically, I need to find the vertex of this parabola. Once I find the vertex, I am done. Okay. Any other questions concerning the specific idea? Okay, now we're going to stay with quadratic for a little bit more. And actually, we're going to come back to this problem. And we're going to talk about zeros of a function. So I need to define the following code. Zeros. What does the word zeros of a function mean? So zeros of a function. Okay. So you have a function f. Oops. So you have a function f, zeros. What do we mean by zeros? It's fairly simple. So the zeros of a function, are nothing more the value of x when the function takes the value 0. So suppose I have this is a function. The zeros are those. Basically the x-intercept, or where the function takes the value 0. So those what we call the zeros of the function. That's what we mean by the zeros of the function. So the zeros of function are the values of x are the values of x when f of x equal to 0. Okay, so to find them very easily. So to find the zeros, set f of x equal to 0 and solve for x. So to find the zeros, set f of x equal to 0 and solve for x. Right? So that's really the idea. So these are what you mean by zero. So it's just a sophisticated word for a very, not a new idea. It means we are asking about those values. Those values. Okay, so let me take two small examples. Suppose I give you example. Suppose I have f of x equal x squared plus 4x minus 5. Find the zeros. Is this a hard or an easy question? So what does this mean? It's nothing more than solving f of x equal to 0. That's really what it means. So this will tell me x squared okay, we're going to try to factor. And this is 5 and the 1. And then x, and then x. And that must be a plus, and that's a minus. Okay, so the zeros here are x equal 1, x equal minus 5. And you know, guys, it's like with very little info, we can sketch this parabola actually. Like we can sketch the graph of this function. So let's look at this function. We know it's a parabola by now because that's a typical quadratic function. And it's a parabola going up. We know that it is 0 at 1 and minus 5. So this is minus 5. And this is 1. So we know that the zeros are here. And this is really give us a very good idea how to graph it. So it means that the graph is going to look something like that. Very little info, not the perfect graph, but that's really give us an idea how to sketch the graph of this function. And what's the value here? Can anybody give me this value? Exactly. What's the value here? This is the value when x is 0. That's the output when the input is 0. So if I put x equal to 0 back into the formula, I get minus 5. And this is minus, by just pure coincidence, we have minus 5 both sides. So this is nothing more than minus 5. Okay, so very little info. Okay, let's see another example of that. Suppose I give you f of x equal x minus 1 times x plus 2 times 2x plus 3. Okay, find the zeros of this function. First, let me ask you a simple question. Is this a quadratic function? Even though I'm talking about quadratic, is this a quadratic function? What can you say? Is this quadratic? Anyone? No, because you're right. No, because if you multiply out, you're going to have x, x, x. You have x to the power 3. Definitely not quadratic. Okay, find the zeros. I'll give you a minute to do that. Okay, any answers? All right, very good. So set equal to 0, very simple. It means each one of them equal to 0, as simple as that. So x minus 1 equal to 0, x plus 2 equal to 0, 2x plus 3 equal to 0. This will give me x equal to 1, x equal minus 2, and this give me x equal minus 3/2. Okay. All right, so finally, the 0 is a quadratic function. And the formula that you guys dread. So how to find the zeros of a quadratic equation, if you want, when we cannot factor. When we can, write it, we cannot factor. If we can factor, we're great. But if we cannot factor, how we can do it, okay? So first, what's a quadratic equation? I wrote the word quadratic equation. A quadratic equation is an equation of the following form. That's quadratic equation. Ax squared plus bx plus c equal to 0. So that's a quadratic equation, okay? Now, so far we solved a lot of those. We solved a lot of quadratic equation, and most of the time we factored. All of them were made, so you guys were able to factor them very easily, and that's what happened. We actually factored them. But a lot of time you can try anything you can, but you cannot factor them. But you still need to solve. And this is where the famous quadratic formula come into the picture. So a quadratic equation is an equation of the following form. Then the solution of it are. When I say the solution, it means the value of x that make this equal to 0. And this is what the quadratic equation tells me. You guys remember it. So the solution are given by, we have two solutions. X equal minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. In other words, we have two solutions. One is the minus b plus that. That's the positive one. And another solution is the minus b minus the square root. So we have a quadratic equation. Okay, and this is telling me whether you can factor it or not. It doesn't really matter. You can find it is 0 by applying the formula. Now, of course, if you can factor it, there is no reason to apply this. I mean, this is like, yeah. So if we can factor it, there is no reason to apply all this. But today we're just gonna do both actually. So let us apply it. Example number 1. So I will remove it. I don't need it. So example number 1. Let me take the following function. F of x equal minus 2x squared plus 4x plus 3. Okay. So, and here it is. The question is, all right, very good. How I am gonna factor this? So if I want to factor, usually I try to factor. I always stare at it a little bit, ask myself, okay, can I factor this expression? Now, with this in mind, you know, looking, what happened? Okay. Looking at it, I had it better. I don't know what happened now. I'll try it one more. Sorry. Okay, I won't touch it. I'll make it worse. Okay, so looking at it, if you try to factor, no, try. The -2 here is going to give us a little bit of trouble. So we are going to use a quadratic formula. I'm going to use it very well. The first step using the quadratic is to say what's the A, what's the B, and what's the C. I don't know why this is doing this to me. Okay, stay like that. Very good. All right. The A here is -2. My B is the 4. And my C is equal to 3. Okay, and let us use this quadratic formula very clearly. So we have two solutions. Usually you can compute b squared minus 4ac by itself and then plug it in, or you can, so I compute b squared minus 4ac. This will give me 4 minus 4 times a times c. So that's 4 times plus, which is 28. Okay, so the solutions are, we have two solutions. One is minus the b plus the square root, and then we substitute everything over the 2a. And the other one is minus the b minus the square root over 2a. Okay, so let's evaluate this. So the first one is minus b minus the 4 plus the square root of b squared minus 4ac. I computed it to make things a bit easier. Over 2a, my a is -2 over -4. Okay, and we'll simplify this tiny bit in a second. And this would be -4 minus the square root of 28 over -4. Okay, now can I simplify this? It will be nice sometimes to simplify this expression a little bit. So let us see. Let's look at this expression. Okay, let's consider first following solution. How can I simplify it? No. The square root of 28 is basically 4 times 7. Correct? Over -4. And now square root of 4 times 7 is definitely square root of 4 times the square root of 7. So this will give me -4 plus 2 square root of 7 over -4. Okay, just a little bit to simplify it. Can I simplify a little bit more? What do you think? Can I simplify tiny more? Anybody would like to do something? Yeah. Okay. What shall I do? Cancel the -4. Uh-oh. Can I cancel the -4? Can I cancel? Absolutely not. Absolutely not. And that's a common mistake. You cannot cancel the -4. Watch carefully. If I have -4, sorry. This and this cannot, hear me, cannot be canceled. Cannot be canceled. Let's take a simple example. If I give you 2 plus 3 over 2, okay, 2 plus 3 over 2. Okay, this is of course 5/2. If you cancel the 2, what will happen to it? You get a 3. Absolute nonsense, because this is 5/2. The only time we can cancel if we have a factor. So it means like if I have -4 multiplied by something over -4 multiplied, it has to be a product, then I can do that. It's a fairly common mistake, and I hope you guys won't do it again. Very common mistake. Very good. So I would like to simplify this tiny bit. Okay, can we do a little bit better? I mean, it's already very good. Okay, one thing we can do is the following. You can, if you want, you can factor out the 2 here, and you will get.
Excuse me, I hate to interrupt, but
What?
isn't it like -4 times -2 times 3, 28, 24? Because that would be 8 times.
Here?
Yeah, you got
Did I do a mistake? Did I do a mistake here?
Yeah, it's -4. You multiply that by 2, that becomes 8, and then multiply that by 3, you get 24. And
Yeah.
and plus, where'd you get the extra 4 from?
That's b squared. Oh.
B squared is 16.
Wow. Why did you wait that long?
I thought you would catch it by then, but
thank you very much.
That's okay.
Okay.
So it's 40.
40. Very good. 40. 40. So this will become what? This will become what? 10, right? And this will turn into 10. Okay, so this will become 2 square root of 10. Okay, thank you very much. All right, so yeah, I think the question is being answered by now. Very good. So one thing you can do, you can factor out the 2 in the numerator, and you will get -2 plus square root of 10 over -4, and you can simplify and you will get -2 plus square root of 10. But now the only thing you can do is you divide it by -2. Okay, it's not divided by 4, but you can divide it by -2. Okay, all right, so let's take up one more problem, and then I think we can almost wrap up this this section. So example number 2. Suppose I have the following function, f of x equal x squared minus 4x plus 4. Okay, and we're going to solve it by factoring, and we can solve it by use the quadratic. Okay, of course I have a reason in my mind why I want to do it both ways. All right, so first let's do it by factoring. That's my equation. Okay, by factoring. So I have x squared minus 4x plus 4 equal to 0. So if you want me to factor, what do you think factoring could give me? How can I factor this? Okay, can you factor it for me? Anybody, it's not hard. Please write your answers. Okay, so basically you'll be looking, so I will do it like this. 2 numbers whose product is 2, and when you multiply them, basically it's 2. Okay, so it's going to give me x minus 2, x minus 2. Or if you want, x minus 2 squared. So this is equal to 0, means x equal to 2. So this the situation actually, and we ended up really with having one solution, x equal to 2. Okay, that's one solution. So if I try to graph the function, so now if I take the function x squared minus 4x plus 4, this function, and I try to graph it, I know it's a parabola going up, But this tells me that it has a 0 only at 2. So it's going to touch the x-axis only here. So basically, this tells me that the function cannot be like this, because if it's like that, it's going to touch it in 2 places. So this is really telling me that your function should look like that. That's the only solution you have. Okay. Now I will do it using quadratic. Okay. So what does the quadratic tells me? Okay, I need the b squared minus 4ac. I like to compute it by itself first, as I said. And in my case here, my a is a 1, that's the coefficient of x squared, and my b is a minus 4, and my c is a 4. Okay, so I'll try not to do a mistake this time. So b squared is minus 4 squared minus 4 times a times c. Okay, and this is definitely 16 minus 16. This is equal to 0. Okay, so b squared minus 4ac equal to 0. So now when I apply the quadratic formula, what's going to happen? I know that we have 2, but the difference between them is one is plus the square root, the other one is minus the square root. But the square root is 0. So basically, definitely, we're going to have one solution here. So we're going to have minus b, which is plus the square root over 2a. But we know that the term, this one is 0. So this will give me minus b, which is a 4, over 2a, which is 2, which is equal to 2. And even if I apply minus b minus the square root over 2a, it's again 4 over 2 equal to 2. Okay, so if b squared minus 4ac is equal to 0, then my quadratic equation has only one solution. We don't have 2 solutions. So if I sketch the function f, x squared minus 4x plus 4, that's the picture we have. Okay, so now we have two situations when my b squared minus 4ac, which is probably some of you know it, sometimes it's called discriminant. Discriminant, that's the name sometimes given to it. So when b squared minus 4ac is positive, absolutely positive, and then definitely because I have plus the square root and minus the square root, I am going to have 2 different solutions of the equation. When it is 0, I'm having only one solution of the equation. And now my last scenario. Please, when I turn the page and you're not done or you want it back, let me know. Now my last scenario is the following. Let me take f of x equal 2x squared plus 2x plus 3. So that's my function f of x. And the question is find the zeros of f, which is another word of solving the quadratic equation. Find the zeros of f. So I'm going to set this equal to 0 and solve. Okay, if we try to use the quadratic, it will not work. So, sorry, if we try to factor, it will not work. We're going to try to use the quadratic. So I'm going to compute the b squared minus the 4ac. And here my a is 2, my b is 2, and my c is 3. Okay, and it's going to give me b squared, it means 4 minus 4 times a times c. And this will give me 4 minus which is minus 20. Okay. Now, of course, you guys should be looking at it with suspicion. So what is happening in this scenario? So what's happening in this scenario and how my function would look like? So if I sit down and find the solution, I'm going to have minus b plus the square root of minus 20 over 4. But definitely the square root of minus 20 is not defined. So this is not defined. And of course, this is not defined. Absolutely not defined. We cannot have a negative number under the radical or under the square root. So conclusion that there are no solutions in this scenario. No solutions. It means no value of x. No value of x. You can plug it in here and it spits out a 0. Nothing could spit out 0. So no solution. Okay, so what does it mean, no solution? It means no matter what x, you plug it, you take it, you plug it in here or in here, it doesn't really matter, same expression, then you will never get 0. How is the graph of this function look like? Okay, who can tell me? How's the graph of this function would look like? Exactly. The graph here, there are no solutions. So the graph cannot, so first it's a parabola going up. It will not touches this line because so the only way the graph would look like has to be something like this. And that's really the graph of this function. It's all about the x-axis. Okay, so conclusion for that, for the quadratic equation. Let's be x minus c equal to 0. So that we have 3 cases. B squared minus 4ac is positive. B squared minus 4ac equal to 0. And b squared minus 4ac negative. Okay. In the first scenario, we have 2 different solutions. Different. 2 different solutions only. In scenario, we have 1 solution. In this case, there is no solution. There is no value of x, which will give us this scenario. Okay, so that's really the idea. Now, let me see if I'm going to go back to the problem that you guys asked at the beginning and finalize this section with it. Before we move on to the last ideas in this course. All right. So let me go back to the following problem that we started with. So we go back to number 15, but I'm going to ask a different question. So number 15. So we have f of t is, we have the ball. We have it's a ball or a stone, and then we throw it. And at any moment in time, f of t is given by the formula minus 16t squared plus 80t and plus 5. Okay, and the question is, so the first question we answered, when does the ball, so that was the picture, that's the stone, and that's how the stone is moving. So that's time. And in the first piece, we found when does it hit its maximum? And now the question is, when does the stone hit the ground? Okay, so question is, when does the stone hit the ground? Okay, so a very natural question. You throw it. Physics tells me that that's the height at every moment in time. That's one of the very famous formulas from physics. Physics tells me that. And now I ask you when. So you throw it at start at 5 feet. When does it hit the ground? F of t is the height above the ground. So f of t is the height above the ground. So it means in terms of the problem, whatever t is, this is how high we are above the ground. That's really what this function is. So now if I want to find when does the stone hits the ground, what shall I do? Quickly. How would you do such a question? Back to you. I'm just actually asking you. If you find the zero, so when does it hit the ground? It's going to hit it here. That's when it hits the ground. It means I have to, and it doesn't hit it anywhere else. I mean, it's not going to hit at 2 places. It's going to hit it right here. So the question is, I need to find when the height is equal to 0. That's really what I need to find. So we have to set minus 16t squared plus 80t plus 5 equal to 0 and solve for t. Okay. Now, of course, just by the look at it, factoring this is actually impossible. So that's where the quadratic again get into the picture, and we have to use the quadratic formula. So my A here is minus 16. My B is 80, and my C is 5. And you guys start computing because you're faster than me. So B squared minus 4AC equal 80 squared minus 4 times minus 16 times 5. Okay, so let us compute this. How much do we get? So go ahead, you guys do it, see what you get. Okay, anybody found it? Okay, I got 6,720. Did anybody get anything close to me? Anybody got anything close? Okay. Now, so what are the solutions? So t, now that we are solving for t, we're going to have 2, of course, and then we're going to figure out which one we have. So t equal minus b minus 80 plus the square root of that over 2a. Okay, and minus 80 minus the square root over 2a. So it's a little bit of computation. It's a nasty computation, but there isn't much we can do about that. Okay, so the first one is minus 80 plus the square root 6,720 over minus 32. And this is minus 80 minus that over minus 32. All right, so let's compute them. Help me out here. So I'll compute the first one. Minus 80 plus the square root of 6,720 divided by negative 32. So I'm getting minus 0.061 in here. And the second one, I'm getting, please do it while I am, because I'm doing mistakes, as you guys notice. by minus 32. Okay, I got here 5.06. Okay, anytime, anybody close to me. All right, so this is definitely doesn't work because negative, and we're dealing with time. So the stone hits the ground after 5.06 seconds. And now we know basically everything there is to know about the stone, all right? Okay, so now what next? So that's basically what you need about quadratic. I mean, there's everywhere, as you guys have seen, and you will see. So basically, what's their vertex, how their graph in general, up, down, the vertex, what the vertex is, and their zeros. Their zeros are important. Okay. Today we're going to start a little bit, section chapter 3, exponential function. Okay, so today I'll start with the introduction, slowly, and then we will get into, we'll start getting into them today, but let's get going. So section 3.1, I imagine. Yeah, 3.1. Exponential function. Exponential function. Okay, so we saw two types of functions so far that you should totally recognize. Linear, mx plus b. Quadratic, ax squared plus bx plus c. Okay, those are the two basic functions that you should totally, you know. Today, we're going to start a new type of function. We still have two functions to study in this course, and they are called exponential functions. So first, what's the form? Let us start with that. So what's an exponential function? So definition. What's the form of it? An exponential function is a function that has the following form. So an exponential function is a function of the form is a function that has the form following form. Okay, f of x equal f of x equal a. It's not the a of the quadratic, just, we call it a, times b to the x. Okay, so where a and b are constant, a, b constant, it means they don't depend on x, a, b constant, a not 0, or this would be 0, and b has to be positive, or this will not make sense. Okay, so that's an exponential function. So in an exponential function, it's important. Let us note that in an exponential function, and that the input, the x, is an exponent. And that's really why the word exponential is coming from. That is an exponent, that x, that the input is an exponent, or the independent variable, whatever we want to call it. The input is an exponent, which is already very confusing. Okay, the input, the x, is actually an exponent. So let us a little bit kind of practice this, understand the notation. So for example, okay, suppose f of x equal 4 times 2 to the x. Okay, all right. So in this problem, what's the a and what's the b? What's the a, what's the b? So 4 times 2 to the x. What's the a in this problem? So we should recognize the pattern. What's the A and what's the B? The A is the 4. The B is the 2. Okay, so let us evaluate this. Let us evaluate. So let us evaluate f of 0. Evaluate a lot of them, then we understand how they work. So f of 0 is 4 times 2. Remember, x is an exponent to the 0. Okay, so it means 4 times. Now, anything to the power 0, anything to the power 0 is a 1. So this is equal to 4 times 1. This is equal to 4. Okay, now I would like to practice a little bit this notation. As I said, what is f of 3? F of 3, it means x takes the value 3. It's 4 times 2 to the power 3. It means 4 times 8, which is 32. It's really a matter of understanding. Okay. So always I'm reminding you that that's the 3. That's the 3. Okay, 2 more. What is f of minus 1? But then you have to give me the answers now. And what is f of minus 3? And what is f of minus a half? Okay, get going. Okay, so get going. What's f of minus 1? I want every one of them. And don't use your calculator. I mean, it's easy to use a calculator. Try not to use it. Okay, the first one, what did you get? 2? Okay, let's make sure. So that's 4 times 2 to the minus 1. Okay, 2 to the minus 1, that's what you have to remember. A number to a negative power is 1 over 2. Okay, I didn't want to use a calculator. I wanted to remember those. Okay, 4 times a half is 4 over 2, which is a 2. Okay, so 2 to the minus 1 is 1/2. Okay, what is f of minus 3? Okay, I'm getting that. So let me see if you guys are right. It's 4 times 2 to the minus 3. Now, 2 to the minus 3 is what? 2 to the minus 3 is what? What's the meaning of it? Otherwise, the whole thing doesn't make sense. What does it mean to raise a number to a negative power? Write it for me on chat. What does it mean to raise a number to a negative power? Remember? Yep, it's 1 over the number to the positive power. Okay, it's 1 over the number to the positive power. So this is 4 times 1 over 8. Okay, which is 4 over 8, which is a half. Okay, all right. Now, f of minus a half. I don't want you to use the calculator, so I don't want an exact, I want an exact answer. I want an exact answer. I don't want a calculator here. Okay, so it's minus a half. Okay, you guys are doing the same mistake. I have a common mistake going on. If that's what I'm reading. Be careful. All right, let's see. First, let's write it correctly. So here, this is my x minus a half. That's my x. So this is going to give me 4 times 2 to the power minus a half. To the power minus a half. Okay, and now again, what does it mean to raise something to a negative power? I mean, it's 1 over a, whatever, this is minus n, this will become a to the n. So this is 4 times 1 over 2 to the power a half. Okay, so we have to be very careful. Now 2 to the power a half is 1 over the square root of 2. So this is equal to 4 over the square root of 2. Okay, so that's how this exponential function, actually that's how we find the value of this exponential function. Now, some terminology, and next time, where those come from? I mean, why do they exist, those exponential functions? And what do they model? What kind of problem they model? But some word. In the formula, so we have the expression, if you want. F of x equal a times b to the x. Okay, then a is called the initial value. Who can explain to me why? It's called the initial value. Okay. So why do you think it's called the initial value? Anybody give, why this is the name given to that? No, it has definitely more meaning than that. It's important meaning though. Yeah, because if I evaluate f at 0 or x equal to 0, watch what we get. We get a times b to the 0, which is equal to a. Okay, and that's important. So a is called the initial value because of that. It means when I start to graph this function, we will graph it very soon. Okay, right here, this is the a. This is the a in the picture. Okay, that's why we give it the name of initial value. B is called, and this has to be explained next time, B is called the growth factor. The growth. So these are words you have totally to be familiar with. This is called the growth factor. So B, we give it a name, and the name assigned to B is the growth factor. Okay, so A initial for very specific reason, that's clear, easy to explain in this problem. B is called the growth factor. This is, we have to talk a lot about it. Okay, so next time we have to talk about why do we care about those functions and where do they come from? I mean, do they really model a real problem? I mean, at the quadratic, they model every time you take a stone and you throw it. The formula is a quadratic quadratic function, but exponential. Okay, what do they model? All right, at this point, I stop the course. Now we have the exam, which was planned for Thursday, and of course, it will not be planned for Thursday anymore. I hate to do that. I don't think I have many choices except having it next Thursday. Will it be all right for all of you? I wanted it to be this Thursday, but there is no way out. Okay, is it okay with all of you? Please put on chat if anyone has any problem with that. All right, you know, I wanted this week, but I mean, I cannot grade or do anything anyway. All right, so this test. Now, you guys stay with me a little bit, and I want to see what's going on with the quiz. So stay with me and let me check your quizzes. And I will send an email to everyone that I didn't get something from. And then it will, hopefully this will help us a little bit. Wow, that's weird. What's happening is very weird. Okay. It seems to me that I have a quiz from everyone, almost everyone. Okay, I'm gonna send you an email, and the email will be sent only for those that I did not receive the quiz from. Okay, so for those who got an email from me, it means I didn't receive that quiz. For those who didn't, it means I've already received it. So, and it seems to me that most of you, I've received their quizzes already. Okay, all right, the class ends for now. See you on Thursday. Bye-bye, guys.